Okay. No, I don't want red. Look how well this stylus works too.
It keeps up.
Yeah.
Yeah.
Well, it's also not streaming meat right now. Wait till I see that. Okay. So RAM literally stands for rectangular. I feel like I need a small one. It's okay. Stop being ADD. Rectangular approximation method. So I'm just going to run through this quickly again because I stopped recording and re-recording. So what this does is this estimates the area under a curve, whether that be the curve like we talked about, the x squared curve, or any type of graph within an interval. It can estimate the area under it. Okay. All right. So let's look at. We'll say that this goes to 1, so nice, 3. Better. It's all coming back. It's all coming back. Y'all don't even know that song, do you? Okay. Let's say I wanted to estimate the area under the curve from 0 to 3. So I'm talking all of this area. And so what I'm going to do is try to use some rectangles to approximate this. And I will define before I start, I'll tell how many intervals I want. That's generally referred to as n. If you played with the calculator program, you saw it asked for n, I think, yesterday. N is your number of intervals. And so what I can do, let's say here I wanted n to be 6. That would mean I'm dividing in from 0 to 3. Divide into 6 equal intervals, and what I'm going to do is I'm going to make little rectangles here. Now I went kind of fast through the other and showed you left, right, and midpoint, but before I do that, I want to stop here just a minute. And I want to talk about how we could actually find the area of these individual rectangles. We have the equation of the curve, which is x squared, yes? How do you find the area of a rectangle? Length times width, right? If I divide it into equal intervals over a set interval, then I know the width of each one, right?
Yes.
What would that be? 1/2. Okay? This is going to be 1/2 every single time. The height is going to be a little bit different. What am I going to have to do to find the height of the rectangle?
It'll be on that point.
That's exactly right. Plug it in the formula of the equation. This point, right? This point is going to be the height. So f of 1/2, which is going to be 1/2 squared, which is 1/4. So this little rectangle right here, if I were to pull it out, would have an area or a length and width 1/2 by 1/4. Does that make sense to you?
Yes.
So the area of just this green would be 1/8. Everybody okay on that? How about the area of the second rectangle? What do you think? 1/2 times what? Times 1, which would be, why can't I do it? Okay, times 1, which would be 1/2. Does everybody see why? I'm finding this point right here because that's my height. If I plug that in, f of 1 squared would be 1. So again, the width is 1/2 and the height now is 1, so the area of this one would be 1. Half. Does that make sense? You see what we're doing? And so we would follow this method. What would the area of this one be?
1. Wait, no, sorry, 2.
No, it's 3/2.
So this is
3/2,
3 over 2,
9
so this would be f of 3 over 2.
9/4 times 1/2 is 9/8.
So 1 and 1/8.
We'll just leave it 9/8 here. How about the area of this one?
That would be.
That one.
I'm finding this for a reason.
2.
This is an easy one. This will be 2? Y'all sure?
Yes.
Yes. And this one?
Oh gosh, 5/2. Would be 25 over 4 times 1/2. 25 over 8.
Okay, trust you.
Well, we did it, but okay.
How about the last one here?
Hold on, this one's a bit.
Okay.
That would be 9 times 1/2.
All I'm doing, and they're just doing it in their head, this is an easy curve, it's x squared. So you find the coordinate of each corner here to find the height, plugging into x squared. This point right here would be 2, and then if you plug 2 into this equation, you get 2 squared, right? Which is 4. So this point, this start is 2, 4. So the height of this triangle is 4. The width is 1/2, and so you multiply those two together to get the area of that one triangle.
Are we gonna ever have to do this by hand?
Yes. And that it is almost always a question on the exam in some way, shape, or form. Is a
Like not like
rectangular
without a
approximation.
calculator?
Without a calculator. Now, to approximate this area, I would add all these together, yes? So, what is this? 1/8 plus 1/2 plus 9/8 plus 2 plus 25 over 8 plus 9 over 2. Right? And whatever that gives me. Let me put it on my calculator real quick. Plus 1/2 plus 9 over 8 plus 2 plus 25 over 8 plus 9 over 2. Did you just do that in your head, Sarah?
Tell me if I'm right first.
What'd you say?
51 over 8.
91 over 8.
Oh,
That was pretty good though. Alright, 91 over 8, so that's my area.
41.
Now, that area, do you think that that is an overestimation, a good estimation, or an underestimation?
It's over.
It's over. How do you know it's over?
Because the squares go past.
That's exactly right. Look how these rectangles are coming up over. All this in yellow is area that I don't need. We're not going to do anything wild and crazy like take that out or anything like that before y'all get all excited. But I just want you to see, and this is a very exaggerated example of why it's an overestimation. Okay. Now, I will tell you that the more intervals you do, the more accurate your estimate becomes. If I divided this into, instead of 6, maybe I did 30, well, my rectangles are smaller, so my overage is smaller, and so it becomes a more accurate. And the more intervals you have, the more accurate it becomes. Now, if you will, take out your, we shouldn't do that just yet. We'll do the calculator later. Well, let's check it and see. On your calculator, now when I use the calculator to do these, you need to put your function in y equals. So go to y equals, and I'm sorry guys, I don't have my TI set up on here just yet, so y'all just have to listen and follow along. So we're using the RAM program. So under y equals, do your x squared. Okay? Come out of your y equals and pull up the program RAM that you put in yesterday.
And click enter.
And click enter, and it should say number of intervals. Well, how many intervals did we want? 6. So hit 6 and hit enter. Left endpoint. What's our left endpoint?
0.
0. We're going from 0 to 3, right? So left endpoint is 0, right endpoint 3. So we said that this was right angle, right rectangle, right, because it's using the right side. 11.375, is that what you get if you do 91 divided by 8?
Yep. You said the left.
I'm sorry.
Yeah, I'm a little confused.
All right, this is right, did I say the what now?
I don't even know how to like really.
After Y1.
Yeah, can you start over?
Okay, in Y1, enter x squared and come out of that.
I think.
Okay.
How do you come out of that?
Just hit second mode for quit. Okay, so come back to your original calculator screen. Now hit program and select RAM, enter,
And then hit enter
and
again.
enter again. Enter, enter. Then it should start prompting you everything you need to input. So it'll say number of intervals. Well, how many intervals did I divide this up in? 6. And then it'll say left endpoint. Well, the furthest left you go is 0, right? So that's 0. And then the furthest right you go is 3. Yeah.
So for me, with the number on top of the sigma be 6?
Yes. I'm pretty sure.
You said the right endpoint is, sorry, the right endpoint is what?
3.
Yes, I'm sorry. Because that's what you're spanning. You want the area from 0 to 3. Good on that? All right. So just to justify that what we got, see how much easier it is on the calculator? Holy crap. All right. This was right endpoint. Notice on your left endpoint that you got, it's a lot smaller. Why might that be?
Because the under.
This time it's going under. So this time if I'm doing the left endpoint, and I won't go through every one of these, but I do want to go through every one of the midpoint ones. All right, let's say same scenario, 3, every half, because I want to do 6 intervals. But this time, instead of coming here and going over, I'm going to start from the left and go over. So I'm going to start here and come over. I'm going to start here and come over. See how my rectangles are different now?
Yes, we can see.
Okay. This time my area is going to be short, right? Do you see that? I'm going to be a little short on the area I need, but it still works exactly the same. It's length times width. My width is still a half. It's my height here that's changing. Does that make sense to you? Is everybody okay on that? All right. Let's talk about midpoint. This, by the way, is your left rectangular
How would you
approximation.
get the height for this one? Would you still plug it into the?
Yes, you're still plugging into the equation.
But would you not get the same thing if you plugged in like the 1/2 squared?
You would, a lot of your endpoints are going to be the same, but the difference is, and this was one thing you were going to figure out, I was going to have y'all work through an exploration. The difference is here, this would be my last endpoint because I start here, whereas on the other one, the last endpoint was at 3 here. So it's just shifting. See, I didn't use this very first one here. So it just shifted everything the other way. James, did you have a question? I'm
Yes.
sorry.
I'm plugging this part in. The D comes from here. So what would I plug in?
0.
It'd be 0 plus,
Because this is now 0 to 3.
so it'd be 0 minus 6. I mean 6 minus 0 right here.
Yes, yes. All right, questions? Everybody okay? Okay.
So when you do it on your calculator, are you supposed to do the same thing for however you do it?
No, they'll be different. So, and the reason they're different is because the left should be a lot less than the, not a lot, but it should be less than the right. Did you not get it? Tell me what you got. All right, let's see, number of intervals was 6, left endpoint 0, right endpoint is 3. Tell me what you got for your left.
I got 11.375 for both.
In y equals, what's your y equals say?
Next to it.
You know what? I bet, did you type your program or did you get your program?
I typed it.
One of your, you accidentally typed the same, remember there was 3 different lines there? That's, you typed the same line twice, that's all. That happened to me too, because it got discombobulated. We just need to delete that program and redo it with somebody that's got the right program. All right, let's talk about midpoint real quick. Let's look at the exact same thing. This one's a little harder. 1, 2, 3. I still want 6 intervals. Are you fixing her program? You're so kind. You want me to wait on you? I'll wait. Like, you know, those elementary teachers that always go, I'll wait. I didn't mean it in a snarky way, though. I was being nice. All right. This is midpoint. So I'm still talking about 6 intervals. 6. But this time I'm looking at the midpoint. So what I want is I want exactly in the middle of these 2.
So rectangles are in the middle.
So your rectangles are cutting through like this with the midpoint lying on the top of the rectangle. So it kind of splits the difference of overage and underage. It's still not an exact, you're still going to be missing some, but see how this one's a little more accurate? It's also a little more aggravating. Because for this one, not only am I having to find the height, but I'm having to calculate the midpoint of each section. My widths are still a half, right? That hasn't changed. Those are still a half all the way across. What's changed is now to find this point, to find the height, I have to do f of, for this one, halfway between 0 and 1 is what?
Halfway too bad.
A fourth, right? So I'm having to find f of a fourth. For this one, and remember my width is how much? 1/2. So this would be a fourth plus a half, so it's f of what? 3/4. You see why this one's nastier?
Yes.
It's harder to work. It's more difficult, but it is a little more accurate. I do want us to work through this one real quick because you'll have to work through one left, right, and midpoint on your homework. So I want to make sure, excuse me, I've shown you how to do it. For this one, this would be f of what?
Will you explain how you're finding the midpoint point?
Okay, so yes, if what I'm thinking is all of these are 1/2 intervals, right? Intervals of a half. So if I take the midpoint of the first, between 0 and 1, 0 plus 1 divided by 2 would be 1/2, right? So I know that this is 1/2. Because these intervals are equal and I'm going exactly to the middle of the next interval, then this space is also a half. So what I can do is just add a half each each time
Okay.
to find the next one.
So you're taking the first one, dividing it by 2, and then
I'm
adding
doing,
the
yeah,
interval?
from 0 to 1/2, and then divided by 2, which would be a fourth. Now, if it doesn't make sense for you to add that 1/2, then think, okay, well now I need to go from 1/2 to 1. So 1/2 plus 1 and divide it by 2, and that should give you 3/4. And so on and so forth as I move through. So here, this would be, what,
5/4.
5/4?
7/4.
Right?
Yep. You just,
You're adding 2/4 because 1/2 each time.
yeah, so you just add 2 on each.
Mhm.
Is that a 9?
Yeah. Well,
Is it the 18 zero when they clear your calculator?
I asked about that yesterday because I wanted y'all to still have this on your calculator. It's never been where they cleared it, but I'm double checking to make sure.
I mean, I know a way around it if they do. Same.
Yeah.
How do y'all know a way around that?
So
It's called
you-
thinking smarter, not harder.
You can do this thing called archiving a program, and the way they clear your calculator is they just clear the RAM.
Right. And so
But
if it's
if
archived,
archived and it's not on the RAM,
It's on the hard drive.
You can't use it until you unarchive it, but it won't get cleared when they clear it.
how did you learn that? When you needed that quadratic formula you programmed in there. All right. Only Logan. All right, so now,
formula in my calculator.
so now as I find this area, I'm doing f of 1/4. Remember, this is x squared. So I'm doing 1/4 squared times the width, which is still 1/2. Does that make sense? Okay, and then I would add them all together. So if I add all those together, I should get 8.9375. And I know that because my calculator just told me. For the sake of time, I won't run through each one because it's almost 9:15. Do you understand the three methods though? The left, the right, and the, okay, and do you understand, yes, in this example, the left approximation is an underestimate, but that's just because of the type of curve I'm looking at.
So not always.
Not, I mean, what if it was something like a square root graph or something, right? Then it's not curved down. Well, now my left approximation is going to be an overestimate. You see the difference? So you have to really know the curve you're working with to understand. Okay. Do this for me. Take your same program, do the exact same thing, but do it in, let's say, 12 intervals instead of 6, and see what happens to your numbers. Do you see they're not as different from each other? They're starting to close in. Try to do like 25 intervals. Don't, if you go too far, your poor little calculator just can't handle it.
I did 300.
It's still thinking, isn't it?
No, it didn't.
Oh, did it? Okay. Well, what did it do with 300? Is it super close?
Let me do it again.
Okay, you definitely have a better
does take a
calculator than me
minute.
because mine's still
Mine all
thinking
around
about
just
it.
calculated. RM.
8.9, 9.0, and 8.9.
See how they're closing in on each other? Because the more intervals that you get, the more accurate your approximation is. And if you get enough in there, they'll come back to really, really close to the actual area. Does that make sense to everybody?
Will they ever be the same?
Say again?
Will they ever be the same?
Yes, if you go up to enough intervals. They'll be the same out to a certain number of decimal places. They'll never be exactly the same. But, I mean, you would take them out,
So this is what integrals are.
finding the area
Yes.
under the curve. Kind of, yes.
So on problems like these, we have to show our work.
I'm gonna be mean and make you show your work on a couple by hand, but then the rest you'll use your calculator for.
pulling.
I know. Number 5, you're gonna find by hand. That's your first one you're gonna do for homework. I'll go ahead and give it to you because I'm not gonna go any further. That's what I had planned to do yesterday after we went over the tests. I was just gonna introduce it to you. But we obviously, so I was gonna go a little further today, but God had other plans.
See, told you.
Okay. All right, 5 is definitely by hand. Let me see. It says to sketch the region. I mean, it's a parabola. It's 2x minus x squared between 0 and 2. And you're 4 intervals instead of 6. So 5 is by hand. And 6 is just doing the same one, but doing it for right and midpoint. So you'll do left, right, and midpoint by hand on number 5 and 6. And then 7 is calculator. The rest are calculator.
Okay.
Yeah. So you should be good. All right. So that's just 1 by hand. That's not bad.
I think I can live with that.
Ms. McGee,
Yeah.
what did you get for the answer for the MRAM for 6 intervals?
For 6 intervals, let me redo it because let me stop.